Welcome everyone. Let me present to you the topic of my PhD, the role of gut microbiota in cystic fibrosis. My name is Blanka Bódy. My vision is to offer a complication-free life for people with cystic fibrosis by investigating the role of gut microbiota in the disease. I will investigate in my two projects the relation between gut microbiota and cystic fibrosis. In my first project, I will compare the gut microbiota of healthy people with cystic fibrosis patients, and in the second one, I aim to investigate the impact that CFTR modulator therapy has on gut microbiota in CF patients. So let's jump to the first project. Between 70,000 and 160,000 people are living with cystic fibrosis worldwide. Here you can see the gut wall of a healthy individual and a cystic fibrosis patient. While the CFTR channel works just fine in a healthy individual, it is dysfunctional in a CF patient, resulting in several gastrointestinal and systemic complications, including a continuous inflammatory cycle. So our aim was to compare the gut microbiota of CF patients and healthy individuals. We included articles reporting about adults and children as well. And our outcomes were alpha diversity, beta diversity, and the relative and absolute abundance of certain bacteria. We have conducted our systemic search in 5 databases and ended up with 12 articles after the search and 2 additional articles after citation chasing. Last week, I updated the search and found 1 eligible article to add to our pool. We could pool our results for 2 alpha diversity indexes and relative abundance, and we could only include beta diversity, absolute abundance, and some alpha diversity indexes into the systematic review part. So let me start with our alpha diversity results. So Shannon index is an alpha diversity measure. It takes bacterial richness and evenness into consideration as well. It ranges from 0 to infinity, with the higher numbers indicating a higher diversity. We have calculated standardized mean differences between the CF group and the control group. We have divided the population to infants, children, and adults. And you can see that there is no difference between CF patients and healthy individuals in terms of gut microbiota in the infant group. However, children with CF have a significantly less diverse gut microbiota compared to healthy controls. So all in all, we can say that alpha diversity measured by Shannon index is significantly decreased in children and in the 2 articles about adults compared to healthy controls. The second alpha diversity index that we analyzed is observed autus. It only takes bacterial richness into consideration. It also ranges from 0 to infinity, with higher numbers indicating a higher diversity. We had children and adults age groups, and looking at the pooled estimate for adults, we can say that alpha diversity measured by observed autus shows decreasing trend compared to controls. This first plot shows our analysis for the follow-up of Shannon index in the infant population during the first year of life. We have compared the gut microbiota of CF infants and controls at 4, 6, and 12 months of age. And looking at the diamonds, we can say that there is a decreasing trend of alpha diversity in CF patients compared to controls, which we have also displayed on this figure. The different colors represent the articles that we have included, and the straight line represents the CF population, the striped line, the control population. So all in all, we can say that CF patients have a decreasing trend of alpha diversity during the first year of life compared to controls. This slide shows our results for relative abundance of bacterial taxa. Relative abundance is a percentage measure. It shows us the percentage that a bacterial taxon takes up from the whole bacterial community. Due to the low number of articles in the age groups, we could only pool Bacteroides and Veillonella taxa in the infant age groups. And looking at the pooled estimates, we can say that there are no significant alterations in the abundance of bacterial toxa in people with CF. So the strength of our analysis that we could analyze age-related differences in cystic fibrosis. Also, we could show the maturation of gut microbiota during the first year of life, and we have a higher evidence due to larger overall sample size. Our limitations are the high risk of bias of the included articles. We only have limited data on abundance, and we could only include articles from high-income countries. So in conclusion, I can say that CF serves as a barrier to the diversification and maturation of gut microbiota. And our research implication is that more studies are needed for the investigation of therapeutic microbiota modulation, and also CF-related factors influence on gut microbiota. So this is the current status of my manuscript, the selected journals, and also the conferences that I have presented our abstract. The second project is about the effect of CFTR modulator therapy on gut microbiota in CF patients, which is a registry analysis. So CF comes with several gastrointestinal manifestations, including dysbiosis. The first core problem is the CFTR gene mutation, which results in insufficient CFTR protein level or function. However, we have a solution so far, the CFTR modulator therapy, which acts by either enhancing the processing and trafficking of CF protein or enhancing the function of the inactive chloride channels. The second core problem comes directly from the insufficient CFTR protein, namely exocrine pancreatic insufficiency, constant medications, including antibiotics, high-fat diet, and also low intestinal pH. So the question really is, to what extent is modulator therapy effective in resolving dysbiosis? So our aim was to investigate the impact of modulator therapy. We included children with CF into our analysis on CFTR modulator therapy, and the comparison was themselves before the therapeutic modality. Our outcomes will be different measures of the composition of gut microbiota. Our hypothesis is that that dysbiosis is reduced after modulator therapy. So our source of data is the Cystic Fibrosis-Related Pancreatic Disorder Registry at Translational Pediatric Institute, which was established in 2018 and has currently 130 patients in it. Our first task was database filtering, then data cleaning. Currently, the samples are being processed at the Institute of Medical Microbiology, and the next step will be the biostatistical analysis of the data that we get. We will analyze the data of 25 patients and 4 time points, a baseline, 6, 12, and 24 months after starting modulator therapy. So all in all, in my projects, I investigate the role of gut microbiota in cystic fibrosis. And I would like to thank you for your attention with the quote, "The man who moves a mountain begins by carrying away small stones." Thank you.
Very nice presentation, Blanka. Thank you. You mentioned that one of your limitations in your first project was the high risk of bias in the included studies. Can you explain what did you find behind this?
Yeah, thank you for the question. So high risk of bias was due to mainly non-matching of the two groups, so the CF group and the control group, as well as the different geographical locations of the groups. So we know that the geographical location impacts the composition of gut microbiota, so this was a confounding factor. And also there were some articles that did not report efficiently how they dealt with the confounding factors. So yeah, basically these were the causes of high risk of bias.
Thank you. Any other question? Katalin?
Congrats. Congratulations on this nice
Thank you.
presentation. My question is if these studies included patients after the lung transplantation or only patients without transplantation?
So all of the articles mentioned that a lung transplantation or basically any kind of transplantation was an exclusion criteria. Yeah. Thank you for the question.
Maybe I lost the line at some point, but you said about the registry that there is around 130 patients.
Yeah, yeah.
But you can analyze only 25 patients. How is that? Why is that difference? Or it's just a pilot? Or
yeah, so it was not an easy process putting together even these 25 patients because some patients are on Orkambi therapeutic regimen, others are on Kaftrio. Some patients do not even receive modulator therapy because they are not eligible. And also because we wanted to analyze different time points, it mattered at what time point did they provide the stool sample. And if they did not, then we could not include them. So most of the patients that we included provided at least 3 stool samples.
But for other future researches, the larger registry will be available, you think,
Yes,
so
yes,
for different
of course.
questions?
Hopefully.